On the morning of February 9, 2026, Ukrainian forces monitoring the front near Petropavlivka in the Kupyansk sector detected an unusual Russian assault formation approaching their defensive positions. According to information from Ukrainian operators of the 14th Separate Mechanized Brigade, the incident began at 6:42 a.m. during what had initially been planned as a routine reconnaissance drone mission over Russian positions and temporary camps located in snowy forest areas around the settlement. The reconnaissance drone had been launched to conduct standard surveillance of the so-called gray zone, separating Ukrainian and Russian forward positions. However, within seconds of reaching observation altitude, the drone's thermal imaging system began to register multiple moving heat signatures advancing through the forested terrain. Operators monitoring the feed from a basement command point several kilometers away reported that the pattern of movement did not resemble a conventional armored column. Instead of tanks or infantry fighting vehicles, the Ukrainian drone identified a formation consisting of a single MTLB armored tracked vehicle, followed by a group of small off-road vehicles. Visual confirmation revealed at least 11 all-terrain vehicles, as well as 2 lightweight Desert Cross-type buggies manufactured in China. Each vehicle appeared to be carrying several Russian soldiers equipped for assault operations. According to the drone footage, the convoy was moving quickly across snow-covered ground despite difficult weather conditions. The vehicles were advancing through icy terrain at speeds estimated at up to 60 kilometers per hour, spreading out and maneuvering between craters and damaged forest areas left by previous artillery strikes. Military observers noted that the MTLB at the head of the column appeared to serve a specialized role beyond transport. The vehicle, a Soviet-era armored tractor commonly used for logistics and support tasks, was equipped with what Ukrainian operators identified as a portable electronic warfare system mounted on its chassis. The system was believed to be emitting powerful interference signals, affecting drone control frequencies within a radius of several hundred meters. At the same time, weather conditions significantly complicated reconnaissance efforts. The attack coincided with a heavy snowstorm that reduced visibility and scattered thermal signatures in the air. Ukrainian drone operators reported that the storm disrupted both optical and infrared observation, making it difficult to maintain a stable video signal. Gusts of wind and ice crystals interfered with sensors and communications equipment. Within minutes of identifying the approaching vehicles, operators began to experience technical problems. Telemetry became unstable, the video signal degraded into static, and the control link with the reconnaissance drone began to fluctuate. The interference was believed to be caused partly by the Russian electronic warfare system mounted on the MTLB, and partly by the severe weather conditions. According to Ukrainian personnel familiar with the incident, the Russian plan appeared to rely on speed, electronic disruption, and environmental concealment. The combination of snowstorm conditions and electronic interference created what Ukrainian operators described as a temporary blind zone in which aerial reconnaissance was severely limited. As the Russian formation advanced, the convoy moved rapidly across the gray zone separating both sides. Reports indicated that the group of light vehicles was carrying approximately 50 Russian assault troops. Their destination appeared to be Ukrainian trench positions belonging to units of the 30th Brigade defending the Petropavlivka area. The sudden appearance of fast-moving vehicles created a serious operational challenge for Ukrainian forces. Standard procedure would normally involve transmitting precise coordinates of an approaching enemy formation to artillery units for immediate fire support. However, electronic interference in the area had reportedly disrupted GPS signals, while radio transmissions risked exposing the positions of drone operators to Russian direction-finding systems. Military specialists explained that Russian electronic warfare systems are capable of detecting radio emissions from drone controllers and other communication devices. Once a signal is detected, multiple antennas can triangulate the source location within minutes, potentially allowing artillery or rocket units to strike the operator's position. As a result, Ukrainian drone teams operating in the area were forced to limit transmission time and frequently change frequencies to reduce the risk of detection. Operators use modified communication firmware designed to switch channels more than 100 times per second and transmit commands in very short bursts. Despite these precautions, the situation continued to deteriorate. As the reconnaissance drone struggled to maintain connection, the Russian column advanced closer to Ukrainian positions. The last stable image received by the Ukrainian operators showed the group of ATVs and buggies accelerating toward the front line, while the leading MTLB continued emitting interference. At that moment, Ukrainian forces faced a critical decision. Continuing active drone operations could allow them to guide artillery toward the advancing vehicles, but it also risked exposing the operator's location to Russian counterfire. Alternatively, shutting down all transmissions would reduce the risk of detection, but leave frontline infantry without aerial surveillance or warning. The operators chose to cut transmissions and power down their equipment in order to avoid being located by Russian electronic warfare systems. Screens went dark, communication stopped, and the observation post fell silent. However, the last images indicated that the Russian assault group was already approaching the line of contact. With drone reconnaissance temporarily disabled and visibility reduced by the snowstorm, Ukrainian infantry defending the trenches near Petropavlivka were left without aerial observation support as the Russian assault force continued its rapid approach across the frozen terrain. The events unfolding that morning would soon lead to one of the most unusual and technically complex engagements reported in the Kupyansk sector during the winter campaign. As the Russian assault group continued advancing through the snowstorm toward Ukrainian positions near Petropavlivka, Ukrainian drone operators attempted an alternative method to transmit targeting information without exposing their location to Russian electronic warfare systems. Direct radio communication with artillery units was considered too risky because Russian direction-finding equipment mounted on the leading MTLB could rapidly triangulate any transmission source. Instead, the reconnaissance drone pilot initiated an improvised maneuver designed to mark the enemy route using a visible thermal signal. The drone descended rapidly from approximately 400 meters, entering a lower altitude zone where small arms fire from the approaching Russian vehicles could potentially reach it. The maneuver was executed near a narrow section of road leading to a bridge crossing the Nilitsia River, an area where the advancing vehicles would have limited room to maneuver. At low altitude, the drone released a small capsule containing a magnesium-based thermal flare designed to produce an intense heat signature. Upon impact with the frozen road surface, the device ignited and began burning at extremely high temperature, producing a bright thermal beacon visible to infrared cameras even through difficult weather conditions. According to Ukrainian personnel familiar with the operation, the flare created a reference point for strike teams operating drones from other positions. The goal was to force the advancing vehicles to pass through the narrow section of road near the bridge, where their movement could be predicted more accurately. The reconnaissance drone then climbed back into cloud cover and withdrew from the immediate area before Russian troops could successfully target it. Operators monitoring the situation from separate positions reported observing the flare's thermal signature through intermittent interference and static. The Russian vehicles continued moving toward the crossing point. At that stage, Ukrainian forces estimated they had approximately 90 seconds before the column crossed the bridge and dispersed into wider terrain where targeting would become significantly more difficult. A Ukrainian FPV strike drone operator then prepared a heavier attack drone configured for close-range engagement. The drone carried a thermobaric TBG-7V warhead weighing more than 2 kilograms, designed to generate a high-pressure blast effective against exposed infantry and lightly armored vehicles. Power was supplied by a 6-cell lithium polymer battery, capable of sustaining only several minutes of high-speed flight. The drone was launched at approximately 8:35 a.m. and accelerated toward the thermal flare, marking the target area. Flying at low altitude to avoid detection and interference, the drone skimmed just a few meters above the snow-covered ground. The operator relied on video feed transmitted to goggles to guide the aircraft along the frozen forest corridor leading to the bridge. However, the mission quickly encountered serious technical difficulties. Ice crystals carried by strong wind struck the drone's camera lens and antennas, while the electronic warfare system mounted on the MTLB continued emitting interference across the spectrum. The video feed began to degrade with horizontal noise lines and intermittent signal loss. At the same time, voltage levels in the drone's battery began to fluctuate under the strain of maximum speed flight in freezing temperatures. Despite these problems, the drone managed to cover the first 2 kilometers of distance with relatively stable control. The operator maintained altitude at approximately 3 meters above the surface, using trees and terrain features to partially shield the signal from interference. Observers later reported that Russian vehicles were also equipped with portable jamming equipment carried by individual soldiers, creating multiple layers of electronic disruption. Ukrainian engineers had previously installed a basic machine vision module in the drone's control system. The small processor, trained using large quantities of combat footage, was capable of identifying certain vehicle shapes and automatically guiding the drone toward them if the pilot lost visual contact. However, the system required at least a brief, clear image of the target to lock on before interference returned. As the drone approached the bridge area, interference intensified. For several moments, the operator lost nearly all visual information and was forced to continue navigation using estimated speed, distance, and direction calculations. The drone accelerated to more than 100 kilometers per hour as the pilot attempted to reach the marked area before battery power dropped below safe limits. Then, during a brief break in the interference, the operator's screen displayed a short but clear image. The thermal flare was visible on the road surface, and in the same frame, the silhouette of the leading Russian vehicle appeared crossing the illuminated area. The machine vision module immediately registered the target and attempted to stabilize tracking. Seconds later, the video signal again degraded as interference resumed. However, the drone had already locked onto the vehicle and continued forward using the last available target data. The operator observed that several additional ATVs and buggies were moving behind the lead vehicle and beginning to spread out along the road. At that stage, the drone was already closing rapidly on the column. Russian soldiers riding on the vehicles recognized the incoming aircraft and opened fire using assault rifles. The drone continued advancing despite incoming fire, its control system attempting to maintain a stable trajectory toward the target. Within seconds, the engagement escalated into a close-range confrontation between the approaching drone and Russian troops defending the convoy. The aircraft continued its final approach under heavy small arms fire as it closed the remaining distance to the lead vehicle. During the final seconds of the engagement near the bridge over the Nilitsia River, Russian soldiers attempted to neutralize the approaching Ukrainian strike drone with small arms fire. According to operational reports from Ukrainian personnel, at least one soldier fired repeated bursts from an AK-12 assault rifle as the drone closed the distance at high speed. The drone continued its trajectory toward the target. Despite the damage, the drone continued its trajectory toward the lead vehicle. Moments later, another Russian serviceman attempted to intercept the drone using a Saiga-12 automatic shotgun loaded with buckshot, a weapon sometimes used in close-range anti-drone defense. Several pellets struck the drone, including at least one impact on the lithium polymer battery pack, which caused a sudden voltage drop visible to the operator monitoring the aircraft's telemetry. Even with severe damage to both propulsion and power systems, the drone maintained forward momentum. According to Ukrainian operators involved in the strike, the flight controller attempted to compensate for the asymmetrical thrust produced by the damaged motor while continuing to guide the aircraft toward the target vehicle. The drone was flying at extremely low altitude, reportedly less than 1 meter above the ground, as it approached the rear section of the MTLB. Russian soldiers positioned on the vehicle attempted to reposition in order to fire again, but the drone was already within several meters. Because the aircraft approached from a low angle near the rear hatch area of the vehicle, it moved below the direct line of sight of at least one soldier positioned on top of the armored compartment. Seconds later, the drone entered the open rear section of the vehicle. At approximately 9:16 a.m., the thermobaric warhead detonated inside the troop compartment of the MTLB. Ukrainian military sources reported that the blast occurred within the enclosed interior space of the vehicle, which contained both ammunition and fuel supplies used by the accompanying assault vehicles. The confined environment amplified the pressure of the explosion, causing catastrophic structural failure. Witness accounts from Ukrainian observation posts described a large explosion, followed by a column of black smoke rising above the forest line. The roof section of the vehicle was reportedly blown off, and fragments of equipment, including parts of the electronic warfare system mounted on the chassis, were scattered into the surrounding snow-covered area. The MTLB was destroyed by the blast. The destruction of the lead vehicle had immediate consequences for the rest of the Russian assault group. Without the electronic warfare system that had been disrupting drone signals, the remaining vehicles were suddenly exposed to Ukrainian surveillance and attack systems. At the same time, the wreckage of the MTLB blocked the narrow section of road near the bridge. According to Ukrainian reports, the ATVs and light buggies that had been following the lead vehicle attempted to stop and maneuver around the burning wreck. In the confusion, several vehicles collided with one another while attempting to turn on the narrow, icy road. One of the vehicles reportedly veered off the roadway and struck an anti-tank mine concealed beneath the snow, triggering another explosion. The sudden loss of the electronic warfare shield and the obstruction of the road halted the momentum of the Russian assault. Ukrainian units monitoring the area reported that the column was forced to stop and reorganize while under threat from additional drone strikes and artillery observation. The disruption prevented the rapid breakthrough that the assault group had been attempting to achieve by using speed and electronic interference. Military analysts note that the engagement illustrates several operational characteristics increasingly visible in the war in eastern Ukraine. Both sides have relied heavily on electronic warfare systems designed to disrupt drone control signals and satellite navigation. At the same time, small unmanned aircraft equipped with relatively inexpensive components have become central tools for reconnaissance and precision strikes against vehicles and personnel. The incident near Petropavlivka also highlights the tactical use of improvised methods to overcome electronic disruption. Ukrainian operators combined a reconnaissance drone, a thermal flare used as a targeting marker, and a strike drone equipped with machine vision assistance in order to attack a moving convoy in conditions where conventional communication and targeting systems were degraded. Frontline units on both sides have increasingly adapted civilian technology and commercial electronics for battlefield use. Off-road vehicles, motorcycles, and other light transport platforms have appeared in assault roles in areas where heavy armored vehicles are vulnerable to mines and anti-tank weapons. At the same time, electronic warfare has become a constant factor affecting communication, navigation, and aerial observation. Following the destruction of the lead MTLB and the disruption of the convoy, Ukrainian units reported that the immediate threat to the Petropavlivka trench line was reduced. However, the broader fighting in the Kupyansk sector has continued, with both sides attempting to gain positional advantage through small unit assaults, drone reconnaissance, and artillery strikes. The events of February 9th illustrate how rapidly evolving battlefield technology, severe weather conditions, and improvised tactics can combine to shape the outcome of localized engagements along the front line. Ukrainian military officials emphasize that similar confrontations are occurring daily across multiple sectors of the conflict. For continuing coverage and detailed analysis of developments on the front line, viewers are encouraged to follow updates and subscribe to the channel for the latest verified reports from the region.